Hello there, we're back, and now we're going to keep moving into Chapter 4 of Math 131. We're going to be looking at finding equations of exponential functions. So I wanted to remind you of the base multiplier property, which we learned of last time, but I'll just put it back out there, which is when you have an exponential function, what happens is as x increases by 1, if you will, the y, or the f of x, gets multiplied by whatever your base b is. So in this case, you can see 25 times 2 is 50. 50 times 2 is 100. 100 times 2 is 200, right? And so on. So you know that your base must be 2 because you're doubling. And we're going to use that property to find an equation. Now remember, there's also one other feature. Hold on, let me make a function. Okay. Then remind you that f of x must be equal to a times b to the x. And we don't bother with the times dot in there because we're lazy, but I mean, that's what it really is. Or a lot of times we'll put the b in parentheses just to make it really clear. Okay? All right, that's your function. Now remember that b is 2. We just saw that because we said, okay, what you're multiplying by, that's 2. So it's 2 to the x. But 2 to the x is no good. You need a number in the front, right? And that's the letter A in the formula. Now, what is it? Well, remember, we already learned it, but it's the y-intercept. So if you look here, you can see 0, 25 right there. That's the y-intercept. Oops, sorry, I want that. Okay, and that must mean that we have 25 in front because that was our y-intercept. Now, keep in mind that if I didn't give this to you, like let's say, hold on, let me make it really awful for you. Okay. There you go. So if I didn't tell you that it was 25, you could still figure it out because if you knew that this was 1 goes to 50, 2 goes to 100, you can tell that you're doubling, right? 50 times 2 is 100, 100 times 2 is 200, and so on. So that means you could figure out what the top number would have been, right? It must have been 0, right? Right? And then it must have been, there we go, 0. And then it must have been 25, right? And you can figure it out even if it wasn't given to you in the table, right? Again, if you multiply by 2 to work your way down the table, then you can divide by 2 to work your way back up. Okay, so there's our equation. F of x must be equal to 25, because that's our y-intercept, times 2, because that's what we're multiplying by, to the x. All right, let's do a whole lot more of it. So we're going to do 4 functions down here. Now, some of them are linear, some of them are exponential. And it's possible, of course, to give you neither, but I didn't do that in this particular example. So our mission is to figure out the possible equations for each. So let me just remind you. F of x is equal, I'm not going to say f of x, I'm going to say y equals mx plus b. This is linear, right? Now, what makes it linear? How can you spot that in the table? Well, you can spot it in the table if you add or subtract the same amount every for every increase in x, right? If you're adding on the same amount every time, how about this way? Add or subtract the same amount as you go down the table, right? So as you work your way down the table, if you're adding on the same amount every time, that's linear, okay? Like, for example, this first one, that's totally linear. Exponential means you're multiplying. So that would be y equals a times b to the x. Okay, you don't have to use the parentheses, but that means you're multiplying or divide the same amount as you go down the table, move down the table. Okay? All right. Now we're going to keep those in mind, and then the general forms can be very useful to us. Now we look at the first one, f of x. So that you want to look at it and try to judge, am I adding the same amount every time? If I am, that's linear. If I'm multiplying by the same amount every time, that's exponential. If I'm doing neither, then that's neither, right? Okay, so f of x, as you can hopefully see, is definitely linear. You're adding the same amount every time. So remember, that's mx plus b. Okay, well, mx plus b, oopsie. Now remember, m is your slope. So m is what you add on every time. So in our case, we're adding on 3. So our slope is 3. So 4 plus 3 makes 7, 7 plus 3 makes 10, and so on. Plus, and then b in a linear equation is your y-intercept. So our y-intercept is 4, because 0 goes to 4. So there we go. So f of x is 3x plus 4. Let me just say 3 equals the slope, which equals the add-on, and then 4 is the y-intercept. It's not really, I should say, 0, 4 is the y-intercept. Okay? Now we get to do it all over again. All right. So hold on, let me box that. There we go. All right, let's do it again. Let's find g of x. All right, g of x is not linear. Now you can tell it's not linear because it's not adding the same amount every time. Because if you get from -4 to -12, you'd subtract 8, right? But subtracting 8 again does not get you to 36. It gets you to 20. So we're not multiplying, or excuse me, we're not adding or subtracting, we're multiplying. 4 times 3 makes 12. 12 times 3 makes 36. 36 times 3 makes 108, and so on. So you can tell that it's a times b to the x. You can tell it's exponential. Now, hopefully you can also tell that that b must be 3. 3 is what you multiply by. So it's not your slope, it's your base multiplier. Base, right? It's what you multiply. Okay? And then our intercept, our y-intercept is 0, -4. So that means that a is -4. And there we go. There's that one. All right, next, what about h of x? H of x is also exponential. You can tell it's exponential because, for example, it won't work all the way. Like if you subtract 48, that gets you to 48 here. But if you subtract 48 again, that doesn't get you to 24. No, 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 no. You're getting smaller, but you're multiplying by a half, right? In other words, you're dividing by 2. 96 divided by 2 is 48. 48 divided by 2 is a half. 24 divided, or it's me. 48 divided by 2 is 24, sorry. And 24 divided by 2 is a half, and so on. Okay, so it's a half that we're working with, right? We're multiplying by a half, which is the same thing as division by 2. And our starting point is 96, right? Because 0, 96 is our y-intercept. So that means that a is 96, excuse me. And then our base is a half because we really divide by 2, right? Times by a half, right? When you divide by 2, you're really multiplying by a half. All right. Oh, I don't have space for all that. Hold on 1 second. There we go. Times by a half. All right, last one. Let's see what I can fit in here. There we go. I managed it. Okay, so the last one, which is k of x. All right, let's see here. K of x. So for k of x, we are subtracting the same amount every time, right? So you take 96, take away 48, take away 48, and so on. So your slope is -48, right? It's a slope because it's what you're adding on or subtracting away, right? In this case, subtract, but okay, what you're subtracting away is 48, and your intercept was 96 again, so that means your back number has to be 96. It's not there. Here. There we go. If I could type. There we go. And there we have it. All 4 functions. So you got to be able to spot which ones are linear, which ones are exponential, and then you have to be able to find the equations for each just in your head. Now I'm going to stop right there before I get into the next example, because the next example is actually a different topic. So I'll pick up there for the next video. See you then.